Hello everyone, this is my presentation of Lab 1 for Physics 2212, spring of 2026. This is Joshua Foreman. Let's get right in. So as an introduction, the purpose of this lab is to examine the behavior of pieces of tape when put under electric force and gravity. The physics principles at play are Coulomb's law for electric force, which says that the force between two objects that have charge is proportional to the product of their charges divided by their distance squared, which points in, and that is all multiplied by the unit vector that is pointing from the source of one electric charge to the other electric charge that's experiencing the field. So the force from the source to the observation point charge is the vector. Gravitational force is also at play in here because we are examining the balance between the gravity on the tape is repelling going in the opposite direction of the force, the electric force from tape to tape. And gravity, the force is proportional, or force is equal to mass times a proportionality constant. That's the acceleration of gravity. Some assumptions that we're making is that the tape pieces are both point charges, which greatly simplifies the math required. And we're saying their point charge is located in the center of mass. We're assuming that both tape pieces have equivalent charge, which makes sense because they're both the same thing. And we're also assuming no air resistance. So an observation that our group had when we were examining the nature of the tape was that it stuck to a hand, that tape repelled from other tape, and the tape attracted to the pen, and the pen was rubbed with hair, which caused it to become negatively charged, which means the tape should have been positively charged. Some calculations that we make when we want to figure out how many electrons could be not doing their job in the tape. We can first calculate the amount of electrons expected by taking the size of an atom and then seeing how many atoms could be in that tape by dividing the size of the atom by dividing the size of the tape by the size of the atom by the size of an atom, knowing the amount of electrons, and then we can calculate the force, equate that to the gravity, because when the tape floats level after we push the tape up close to each other, we can calculate the force, calculate gravity, and be like, okay, they're equal because the tape is level, and so it's not moving, and everything's all good. And so we can do some algebra from those formulas, and we can figure out the charge of the tape. And because we know the charge of the tape, if we know the charge of an electron, we can just divide out and find out the amount of electrons expected to be on the tape. Here's the computer code to show all that I just said, as well as to make the vectors with computer graphics using the calculations made. And so what if the electrons have positive charge and protons have negative charge? Nothing would actually change because all that matters is that opposite charges attract and that like charges repel. And so if that doesn't change at all by switching the role of positive and negative, because as long as like is like and not alike is not alike, everything works out. Why should we handle the tape minimally? Because every time we handle the tape, we're changing the charge of the tape because the sticky stuff comes off. And so if we're using the same piece of tape and doing different things with it, if we want to calculate stuff, we would have to account for the fact that the tape no longer has the properties that we wanted from an original calculation. That's all I have. Please grade generously. I like to grade generously. Yeah, have a good one. Stay warm.